per disulfuric acid, that is Marshall's acid, on hydrolysis with 1 mole of water gives Carros acid and sulfuric acid. So during this reaction, how the oxidation state of sulfur changes from what value to what value? What oxidation state to what oxidation state we need to find. So if we know the equation involved for the reaction, Marshall's acid, that is H2S2O8 on hydrolysis, that is adding water, gives what? The products also mentioned, Carros acid. What is this Carros acid? That is one point which we need to know. So Carros acid is permonosulfuric acid H2SO5 and sulfuric acid H2SO4. So if we observe this equation, we find that in Marshall's acid there are 2 atoms of sulfur, whereas in Carros acid there is 1 atom of sulfur, in sulfuric acid there is 1 atom of sulfur. So we need to find during this reaction how oxidation state of this sulfur changes from what oxidation state to what oxidation state in the products. For which purpose we need to know the oxidation state of sulfur in Marshall's acid per disulfuric acid H2S2O8, and also we need to know in H2SO5 and in sulfuric acid. But we know in sulfuric acid H2SO4 the oxidation state is +5 straight away. So in H2S2O8, by normal method if we work it out, oxygen being -2, hydrogen being +1, -2 into 8 -16, out of -16 +1 into 2 +2 is already there. So -14. So each sulfur will have an oxidation state of +7 when sulfur is 6th A group of the periodic table. How is that it can have an oxidation state more than its group number? The maximum oxidation state for sulfur is supposed to come out as +6. So this indicates that this Marshall's acid has got peroxy bonds. So thus we need to go for the oxidation state of sulfur only +6. Whenever the oxidation state of an atom of the element belonging to a particular group comes out to be more than its group number, we need to bring it back to the group number itself, which can be confirmed by making use of the structure of Marshall's acid. Now these 2 oxygen atoms are in peroxy linkage. So each of the oxygen atoms is -1, -1. So when we now work out the oxidation state for this sulfur and this sulfur, what do we find? This oxygen is -2, -2. So sulfur is +2, +2. With respect to this oxygen, +1, +5. With respect to this oxygen, +1. Totally is +6. And this sulfur atom and this sulfur atom are identical, with 2 oxygen atoms being connected by double bond and 1 OH group, 1 this oxygen. Here also it is similar. Therefore this sulfur also will have +6. That's how it comes out to be +6, the group number itself. So thus sulfur of per disulfuric acid exhibits an oxidation state of +6 each. Then what about Carros acid H2SO5? This is per monosulfuric acid. Here also, if we work out by normal method, -2 into 5 -10, out of which +2 is there. So -8 being left over, it comes out to be +8. So how come this sulfur can have a +8 as an oxidation state? It's more than the group number. Therefore, we need to understand that there should be at least 1 peroxy bond which makes sulfur to have an oxidation state of +6 only. So this sulfur is supposed to have +6. That can be understood from its structure, HO, O, S, double bond O, S double bond O, OH. And this oxygen is -1, this oxygen is -1. And we need to find the oxidation state for this sulfur, where with respect to this oxygen, it is +2. With respect to this oxygen, +2. With respect to this oxygen, +1. That is +5. This one, with respect to this oxygen, 1 more +1. So it comes out to be +6. So thus, the oxidation state of sulfur is +6. And whereas in sulfuric acid, as we know, HO, S double bond O, S double bond O, OH, sulfuric acid. So sulfur of ic acid is +6. And we can calculate by normal method and cross check. So we find the oxidation state of sulfur in H2S2O8 as +6, in H2SO5 as +6, in H2SO4 as +6. Where is the change in oxidation state? So there is no change in oxidation state. Now let us check the answers. During this reaction, oxidation state of sulfur changes from +7 to +8. There is no change at all. +7 to +6, +6 to +4. In ABC, a change is indicated. But here, there is no change. So therefore, no change in oxidation state of sulfur takes place. So it's not a redox reaction. Therefore, D is the right option.